Good morning. I have a question from page 32, numbers 13 and 19. The person asked about 19a, but I'm going to do all three, A, B, and C. Starting with 13, though. 13 asks us to graph the solution set for the given domain. And the domain we're given is the set of positive numbers. So domain you have to think of as if like you're in a store, and the only thing they sell there is positive numbers. So if you go in there and you need anything but a positive number, you won't get it. And so let's see what happens. So we have this equation or inequality, 3 minus 2x is greater than 5. So to solve that, we want to isolate x. We're going to subtract away 3. 3 is positive, so we have now negative 2x is greater than 2. We're going to divide a negative 2, which of course we know means 2. Flip the inequality when we divide by a negative. This gives us a positive x is less than a negative 1. So x is less than negative 1, but we're in a store that only sells positive numbers. So how can we get an answer? Well, unfortunately we can't. So there is no solution to this question when we're in a domain that only has positive numbers because we need negative numbers to answer it. Is there any positive number that would solve this? It doesn't seem that there is. This has to become a positive number here in order to be greater than 5. So we need negative numbers, and in order, because you have negative 2 times something that has to become positive, so it's got to be a negative number. So therefore, there is no solution to this. That means there is an empty set as the solution. I can't really graph that. I mean, I suppose I could say, well, x is not negative 1 by putting an open circle, and it's not that. I mean, but I wouldn't even do that. This is the answer here. There's no answer. The answer is that there is no answer if this is your domain of positive numbers. So the second question we have is question 19, which has three parts to it. Question 19 asks us to similarly solve and graph the solution set to an absolute value question, which is the absolute value of x plus 2 is less than or equal to 3. So A tells us to find x's that are elements of the set of real numbers. B asks us to find solutions of x's that are elements of integers, of the set of integers. And C asks us to find and graph the solution when x is an element of the set of positive numbers. Now notice it doesn't say positive integers, because when I first did this, I misunderstood what domain I was in, and I made a mistake. But I'm gonna hopefully not make that mistake right now. Here we're going to solve this inequality by remembering that whenever you're solving an absolute value system, keep in mind that the absolute value of a number, like suppose I said the absolute value of 3, means how far from 0 are you, so that would be 3. And the absolute value of negative 3 is also 3 units from 0. So I really have two things to solve whenever I have an absolute value expression. So x plus 2, so I'm going to solve 2. I'm going to solve one that looks just like what's given, and one that negates what's inside the absolute value symbol. I negate what's inside, you can negate what's outside. It doesn't really matter that much, but keep in mind that absolute value by definition is the distance from 0, and so it can be the positive or negative inside the absolute value. I use the definition when I solve it. Okay, so we solve by subtracting 2. Subtract 2, so x is less than or equal to 1, and here we're going to add 2. Now we have negative x is less than or equal to a 5. But this negative x is not what we want. We want x, so we need to divide a negative 1. So x is now, remember, flip this. X is greater than negative 5. Now for A, we can graph any real number. So no imaginary numbers, only real numbers. But that's pretty much any number on the number line. So x is between negative 5 and 1. Okay, and then it includes the endpoints of negative 5 and 1. So I will shade between them. And you should always check your answers, especially with absolute values, because sometimes we do all the math correctly, but then it turns out it's actually not an answer that works, and it's usually because of a problem of a negative. So we're going to check. What about we check what we think is in the solution? We'll check 0, for example. So let's put 0 in here. 0 plus 2. 0 plus 2 is 2. The absolute value of 2 is 2. And 2 is less than or equal to 3. So 0 seems to be a solution in this example. And that's good because I have it shaded. Let's check negative 10, which we don't have in the solution, but we want to see. Should it be in there? Why is that not a solution? Negative 10 plus 2 is negative 8. And the absolute value of negative 8 is 8. And 8 is not less than or equal to 3, therefore negative 10 is not in my solution set. Positive 10, similarly, positive 10 plus 2 is 12. Absolute value of 12 is 12. 12 is not less than 3, therefore 10 is not in my solution set. So it looks like I have graphed correctly the set of numbers that solves this absolute value inequality from the domain of real numbers. And I'm shading all the numbers in between. The positives, negatives, rational and irrational numbers, the integers, the fractions, everything. Okay, but B changes my domain. Now I don't really have to redo the work here because I still have this idea. I've solved it. But the domain has changed to be only integers. So what does that mean? Well, here's negative 5, 0, and 1. So between negative 5 and 0 is negative 1, negative 2, negative 3, and negative 4. And if I'm in the set of integers, then those are in my solution set. So negative 5 is, negative 4 is, negative 3, negative 2, negative 1, 0, and 1. That's off a little bit. Let me just change this, move this so it looks a little more consistent. Okay, so these dots represent negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1, which are integers in the domain of integers, and they are solutions to this question. So only integers between negative 5 and 1 satisfy the solution to B. And then C, we have positive. X is an element of the set of positive numbers. So positive numbers, we know, are all the numbers to the right of 0. Okay, so here's 0, here's 1, here's my negative 5. Okay, so any negative answer is not in my domain. I'm in a store that doesn't sell negative answers, so I can't put that in my answer because my domain is only positive numbers. 0 is neither positive nor negative, so we're not including 0. But everything to the right, it says positive numbers. It doesn't say positive integers, so I'm including fractions and irrational numbers. You know, the square root of 2 is in there. Actually, sorry, the square root of 2 is greater than 1. It's not in there. But everything between 0 and 1, and including 1, because 1 is actually in my, it is a positive number, and it is in a solution. So I'm going to shade in the 1, but I'm not shading the 0. I'm putting an open circle at 0, and then I'm going to shade everything in between. Why shading everything in between? Because all of these are positive numbers. Why isn't 0 in the answer? 0 is not a positive number, so I have a store that doesn't sell 0. Even though 0 would be in my solution in A, it is not in my solution in C because we only have, in the domain, we have positive numbers. So I have to leave that circle open to indicate that everything to the right of 0, but not including 0, is in my solution when the domain is the set of positive numbers. But it only goes up to positive 1, and it includes positive 1 because we have this equal sign here. So x is less than or equal to positive 1, therefore I'm shading in the positive 1. Please let me know if this helps. If you have any other questions, I'd be happy to help out. Thank you for watching.